The learning objective for section 5 is to determine if two given structures are the different conformers of the same molecule, or if they're different structural isomers, or if they're different molecules completely. Molecular formulas and condensed structures do not imply shape. If you go back to the previous discussion, you will see that a molecular formula just tells you what elements are present and how many of those elements are present. It does not give any indication as to the shape. The condensed structure, additionally, does not give any indication to shape because it just tells you who's connected to who, how many hydrogens are bonded to the carbon, and how long is the carbon backbone. But it really doesn't imply any shape. Line formulas give a limited feel for the shape of the molecule. If you think about it, the line formulas did show that when you have a carbon-carbon, when you have the intersection, it does form an angle. So it does start to demonstrate that molecules have shape. But still, line formulas are going to fall short unless you use dashed and wedged lines to indicate whether a bond is coming towards you or whether a bond is going away from you, whether the bond is in the plane of the paper. Now, this is a challenge because we do not have a very good way to illustrate in a 2D format something that is 3D. And that's what molecules are. They are 3D structures. And you really have to think about the tetrahedral shape that these molecules in an alkane, or these atoms in an alkane, take. Because once you start thinking about 3D structure, then you can see how the atoms can rotate around a single bond. And as these atoms rotate around a single bond, they can give rise to an infinite number of three-dimensional geometries called conformations. So basically, what I will do in class is I'm going to bring in a molecule set so that you can actually see this rotation and how just because we're rotating the molecule does not change the molecular formula. It does not change the line formula per se, but it does start to change the conformation or where all the hydrogens are located. Each individual conformation is called a conformer, which are simply molecular structures that have identical connections between atoms where the interconversion around a single bond C rotation result only in a different spatial arrangement. Now, we're not going to spend a whole lot of time on conformers. They're not, they are important because we're going to find out that conformers play a particular role when it comes to physical and chemical properties, especially once we start getting into functional groups. But we're not going to spend a whole lot of time just going over a conformer, but I still want you to be able to recognize a conformer. So what is the best way to tell if you have a pair of conformers? And the best way to tell if you have a pair of conformers is actually to name the molecule using an IUPAC system. Because if when you name the molecule using an IUPAC system, they have the exact same name, then they are conformers. If they have a different name, then they are not conformers. They're different molecules. And so IUPAC naming is going to be helpful in determining whether or not you have conformers or whether you have different molecules. And that is what the next section is all about.